My name is Gian Smith, and we have our corrections for test number 1 here. Starting off, we have 1AC base 16 to base 2 to base 8. First, we're going to take the binary representation of each decimal. So for 1, we have 0001. For A, we have 1010. And for C, we have 1100, which would give us 0001110101100 base 2. From there, since we're going to base 8, we're going to take we're going to take 3 digits starting panning from right to left in order to get the representation for base 2 to base 8. So starting off, we know that 001 is base 4. Saying that because this 0 would be 1, and this would be 2, and this would be 4 in our twos chart. And for 5, or for 101, we know that it's 5. And for 110, we know that it's 6. So that would equal us 654 to base 8. Next up with number 2, we have to provide the steps for 1AC base 16 to a decimal. So the steps for that would be 1AC base 16 to base 2, then to base 10, which is the decimal. We have to go to base 2 first because we aren't able to go straight to or from base 16 to base 10 itself. We have to convert it to binary first. For number 4 and 5, we have hexadecimal to octal. The first one is 5D to octal, which is base 8. So first we're going to get the binary representation. So for 5, we have 0101. And for D, we have 1101. We know this because of our twos chart. And we can check this because for 5, we know that the first digit in the twos chart is a 1, the second one is a 2, the third one's a 4, and the fourth one is an 8. So 1 plus the 4 would get us 5, and the same thing for D. So that binary representation would equal out to 001, 011, 101. We then take this and group it by digits or group it by groups of 3 in order to go from binary to octal. And for this, we get 5, 3, and 1, and that gives us 5D base 16 to 135 base 8. For C9, we know that C is 1100, and we know that 9 is 1001. This binary representation together is 01100 1001. We group this by groups of 3. Then we get 311 for our groups, or for our representation of the octal. So C9 base 16 to base 2 is 011001, and then from base 2 to base 8, that would be 311. So C9 base 16 to base 8 is 311. For 6 and 7, we have octal to hexadecimal. We know that 716, we have to break it down into binary digits before we convert to hexadecimal. With this being said, for 7, we get 111. For 1, we get 001. For 6, we get 110. We know this by using our twos chart as well as just practicing with it and knowing the binary representations of the decimals. So altogether, we got 0001, 1100, 1110. And this equaled out once we break it down to groups of 4, because we know this is hexadecimal, not octal. Octal is groups of 3, and hexadecimal is groups of 4. So when we group them in groups of 4, we get E, C, and then 1. And then we can transform, or not transform, sorry. After 10, our decimal then transforms to numbers. So A will equal 10, B will equal 11, C will equal 12, and then so on. So this is where we get these quote-unquote letters from, which are representing the decimal numbers after 10. So for this, we get 716, base 8 to base 16, and that equals 1 CE. For the second one, it's 234 base 8 to base 16, or octal to hexadecimal. We get the binary representation first, which for 2 it is 010, for 3 it is 011, and for 4 it is 100. All this together is 0000. Actually, sorry, all that together would start at this 0, but we had to pan left and fill in the rest of the zeros. So it would be 0100 11100. And then grouping my 4 again, this will equal C, this will equal 9, and the last 4 will equal 0. And so we don't count the last 0 since there's no representation at all, it's just all 0, and we would get 9C. So 234 octal to hexadecimal is 9C. For number 8, we have the difference between hardware and software. So the definition of hardware, or not the definition, but the simple meaning of it, is physical info within the computer. And then software would be basically what, like, it's telling the hardware what to do. So one more time, the hardware is the physical info within the computer or the database, and the software is the coding, or pretty much telling the hardware what to do. And for number 9, we have the concept of abstraction. As we discussed in class, this would pretty much be to hide the details in the data. For number 10, we have the 2 characteristics of vacuum tubes, one of them being to store information, and the other one being that it overheats and that it wasn't reliable. For number 11, we have the difference between bits and a byte. A bit is just binary digits, and a byte is 8 of those bits. So 8 of those binary digits would create, or would get your byte. For number 12, we have the concept of base of a number system. The base of a number system is just the number of digits represented in that number system. And for last but not least, I believe this was question 15, if I am not mistaken. Give me 1 second. And for last but not least, I believe this was question 14. I didn't actually put it. I can check. Oh, wait, no, this wasn't labeled a question. So for the last figures side, we got Hollerith. He was the father of modern machine data processing, and he also created the invention of the punch card tabulating machine. And that finally concludes our test 1 corrections.